compound interest. Now, if you remember the exercise we did in the last simple interest video, we are taking an example of a principal of 10,000 at a rate of 5% and for a period of 3 years. And we had calculated the simple interest based on the initial principal only. And we had set that for after the first year, for a principal of 10,000 at a rate of 5% per annum, we would earn an interest of 500. And the second year, the same thing. The third year, the same thing. Now, how does this change when the interest is being calculated on a compound interest basis? The difference is that instead of calculating our interest based on the initial principal only, after each year, we add the interest to the initial principal to form the new principal for the second year. So let's do that here on this side so that we can understand exactly what we're talking about. So in this case, after the first year, year one, the principal is 10,000 naira because that's what we're starting with. And at 5%, 5% of 10,000 is equal to 500. But for the second year, our principal is no longer 10,000. For compound interest, for the second year, we have to add the initial principal to the interest earned for the year and then compute our interest for the second year based on the new principal. So the new principal for the second year would be 10,000 plus the interest of 500 earned, and that would be 10,500. So the new principal here is going to be 10,500 at 5%, and that will be 525. So the principal for year 3 is going to be this principal plus the interest that was earned for the year, and that's going to be 10,500 plus 525, 5201, 11,025. So the new principal is going to be 11,025 at 5%. So the interest for year 3 would be 551 plus 25. So the total interest earned after 3 years on a compound interest basis on 10,000 is going to be 500 plus 525 plus 551.25, and that's going to be 1,576.25, which is obviously more than when the interest is calculated on a simple interest basis. So the main difference between calculating the interest on a compound interest basis and a simple interest basis is that on a simple interest basis, the interest is computed for each year only on the basis of the initial principal only, as in this case 10,000 for each year. However, for a compound interest, the interest for the year is added to the principal to form the principal of the following year, as we've done here. Now in this case, we cannot continue to do this, so we have to have an expression, a formula to calculate this interest or the amounts that we earn at the end of this period over a period of time. So let's do that here. If we have our principal here, interest here, and the amount here. So the amount is going to be equal to the principal plus the interest, and it's going to form the amount. Now for the first year, for year 1, we have the principal as simply P. And for the interest, it's supposed to be PRT. But we know that T is 1 because we're only calculating for 1 year. So let's get rid of that T since it's going to be 1 and just leave it as PR. So the the amount for year 1 is going to be equal to P plus PR. That's principal plus the interest. Now we have P common to both sides. So if we bring that out as a common factor and we divide P by P, what we have here is 1. If we divide PR by P, we have R left. So 1 plus R. And our amount for this year is going to be P1 plus R. Now let's get rid of this and move to year 2. For year 2, our principal for year 2 is going to be the new amount here, which is going to be P1 plus R. For the interest is going to be the principal multiplied by the rate. So that's going to be P1 plus R multiplied by R, the rate. So that's the principal, which is what we have here, multiplied by the rate. Now the amount for year 2 is going to be P1 plus R, that's this, plus P1 plus R, which is the interest end for that period. Now in this case, we can see that P1 plus R is common to both sides. So if we bring that out as a common factor, P1 plus R. Now if we divide this entire thing by P1 plus R, this cancels out to give us 1, so we have 1 here. And if we divide this by P1 plus R, P1 plus R cancels P1 plus R, we are left with R. Now we have P1 plus R multiplied by 1 plus R. If you have X multiplied by X, this equals X squared. So in this case, we can tell that this is going to be equal to P1 plus R squared as well. So our new amount is P1 plus R squared. So let's get rid of all this and solve for year 3. Now for year 3, our new principal is P1 plus R squared. And the interest is going to be our new principal multiplied by the rate. Now the amount for that year is going to be the principal plus the interest end. So that's going to be P1 plus R squared plus P1 plus R squared R. Now we can tell that P1 plus R squared is common to both sides. So if we bring that out as a common factor and we divide this by P1 plus R squared, that's going to result into 1. If we divide this side by P1 plus R squared, that's going to leave us with R. Now we know that X squared multiplied by X is equal to X cubed. And that means this is going to be equal to P1 plus R cubed. So the new amount here is P1 plus R cubed. Now let's get rid of this. Hopefully by now you would have seen a pattern emerging. And that pattern is that if we have a year T, for example, which could be any number, you can tell that the amount would have at the end of the day is P1 plus R raised to power T. Because for year 1, we have, this is year 1, we have P1 plus R raised to power 1, which we don't need to write. But for year 2, we have P1 plus R squared raised to power 2. For year 3, we have P1 plus R raised to power 3 cubed. And that stands to reason that for year T, we would have P1 plus R raised to power T. So our main formula for compound interest is P1 plus R raised to power T. But it's also possible that instead of, if we have a whole year, as this is January to December, and this is the entire period of a year. Now, it's also possible that the interest is compounded semi-annually. let's say after 6 months. So this is going to be done twice a year. If we have that as from January to June and from July to December. So in this case, what we have is that the rate that should be per annum would now be applicable only to half of the year. So we have this to be R over 2, R over 2. And because the number of times that we would be doing our compounding would be multiplied by 2, because this we have 2 periods now. This is going to be, there's going to be a 2 here. Now, if we have it done quarterly, so let's say this is January to March, this is April to June, this is June to September, and this is October to December. What we would have in this case is R, the rate is going to be, instead of being for a year, it's going to be R divided by 4 for this particular period, which is a quarter, R over 4 for each of those quarters. So in essence, what we would have is this formula is going to evolve into P, which is unaffected, 1 plus R over the number of periods we have raised to power NT. So the rate is going to be affected by the number of periods we have. In this case, if it's semi-annually, we'll have 2 periods. So you divide this by 2. If it's quarterly, it's going to be 4 periods in a year. You divide this by 4, and you have to multiply. You have to multiply the power of this entire thing by the number of periods as well. We'll do some exercises to buttress this point later. One other thing to note is that this is actually the formula for the amount, not the interest. And we know that the amount is equal to the principal plus the interest, which means that the interest is going to be equal to the amount minus the principal. When this is the amount, so interest is equal to amount minus principal. We know that this is the amount, which is P, 1 plus R over NT minus principal. Now P is common to both sides, so if we factorize P out, we would have P as a common factor. That this P cancels out this P, so we have 1 plus R over NT minus P over P. This P cancels out this P to give us 1. So these are the 2 formulae that we require for solving compound interest problems. The first one is the amount, P, 1 plus R over N raised to power, and the other is the interest, which is this. Now we should just note that P equals principal, R equals the rate, N is equal to the number of periods, and that's it. Now T equals number of years. So let's go ahead and solve problems. So the first question we'll be solving says, if you invest $150 in a project and after 2 years you can sell the investment, you would earn 5% paid annually. How much would you have at the end of year 2? So in this case, we're requested to find the amount. We've been given a principal of $150. The time is 2 years. The rate is equal to 5%, which is equal to 0.05. And the periods in a year is 1, because here we've been told that the rate is paid, the interest is paid annually. So it's paid once in a year. If it was quarterly, then we would have 4 periods in a year, but N in this case is 1. So if we remind ourselves of the formula for amounts, which is P 1 plus R over N T. In this case, N is equal to 1, so we can simplify our formula by saying A equals P 1 plus R T. And so amount is equal to principal is $150, 1 plus 0.05 raised to power T, which is 2 years. This becomes 150. 1 plus 0.05 becomes 1.05 squared. And that's equal to 150. 1.05 squared is equal to 1.1025. And this becomes $165.375. And that is the amount that we would have at the end of 2 years. Now, if you want to evaluate the interest from here, all you have to do is simply subtract the principal from this amount, and you have 15.375, and that's the interest accrued over the period. The next question says you have an investment proposition in front of you where you would invest $1,000 on a project, and after 4 years you can sell the investment. You would earn 4% paid annually. How much would you have at the end of 4 years? The same thing. In this case, our principal is $1,000. Our time is 4 years. We have our rate as 4%, 0.04. And in this case, the interest is paid annually as well. So N is equal to 1. So we know that for the amount, when N is equal to 1, our formula is simply P 1 plus R raised to power T. So amount is equal to principal is 1,000, 1 plus R, which is 0.04, plus the T, which is 4 in this case, equals 1,000, 1.04 raised to power 4. This becomes 1,000 multiplied by 1.1698, and this is equal to $1,169.8. So that's how much we would have at the end of 4 years if this investment is done. For the next question, we have that if Jeb had an investment opportunity where he would invest $100 at a rate of 5% per annum, and after 2 years liquidate the investment, if the interest is paid quarterly, how much will Jeb have at the end of the investment? Now, the principal in this case is $100. We have the rate as 5%, which is equal to 0.05. We have the time as 2 years. And we were told that the interest is going to be paid quarterly. So N in this case is going to be equal to 4. Because if you divide a year into quarters, you have 4 periods in that year. If you divide it into 2, if we were told it was going to be paid semi-annually, we would have 2 periods. So quarterly means 4 periods in a year. So that's why we have 4 here. And the amount, the formula for calculating the amount in this case is P into 1 plus R over N raised to power N multiplied by T. So this is going to be equal to P is 100, 1 plus R is 0.05, N is 2, N is 4 rather, sorry, and N is 4 multiplied by 2. We'll have A equals 100, 1 plus 0.05 divided by 4 is equal to 0.0125, and 4 times 2 is 8. So this becomes 100, 1.0125 raised to the power 8. Now, 1.0125 raised to power 8 is equal to 100, 1.10449, and the amount after 2 years of interest paid quarterly is equal to $110.449. Now the next question says that the compound interest on 30,000 rupees at 7% per annum is 4,347 rupees. The period in years is. So here we have the principal as 30,000 rupees. We have the rate at 7% per annum, which is 0.07. We have the interest as 4,347 rupees. Here we were not told if it was compounded annually or quarterly or whatever, so we assume that it was compounded annually since we don't have any information about that. And here we were asked to find the time. So the amount is equal to the principal, which is 30,000 plus the interest, and that's going to be equal to 30,000 plus 4,347. So the amount at the end of the period is 34,347 rupees. So we have our amount equals P 1 plus R raised to power T, and we're looking for T. So 34,347 equals our principal, which is 30,000, into 1 plus R, which is 0.07 raised to power T. Now this becomes 34,347 equals 30,000. 1.07, 1 plus 0.7 becomes 1.07 raised to power T. Now, we're trying to make T the subject of the formula here, so we're looking for a way to isolate T here on this side and move every other thing to this side. The first thing we need to do is divide both sides by 30,000. If we divide both sides by 30,000, that would eliminate 30,000 here to make it 1, and then we have 30,000 here. So we have 34,347 divided by 30,000 is equal to 1.1449 equals 1.07 raised to power T. Now, to make T the subject of the formula here, first we have to bring T down from this level of being a power. And if you're familiar with the laws of logarithm, you would know that log y raised to power x is equal to x log y. So in this case, if we find the logarithm of both sides, we have log 1.1449 equals log 1.07t, and that's going to be equal to log, let's create space for ourselves, log 1.1449 equals t log 1.07. So now we can divide both sides by log 1.07 and leave t on this side by itself. So if we do that, we'll have log 1.07 here, divide this by log 1.07, and this cancels out this. Now log 1.1449 equals t equals log 1.1449 equals 0.05876, and log 1.07 equals 0.02938. So t equals 0.05876 divided by 0.02938, and that is exactly 2. So our time period is 2 years. So the period for which he has to invest 30,000 rupees at 7% per annum with interest compounded annually is 2 years. The next question says that find the rate per annum at which $125,000 must be invested on a compound interest basis with interest compounded quarterly for 9 months to yield an interest of 7,651. So in this case, we have our principal as $125,000. We have our rate. Okay, rate is what we're looking for. We have our time as 9 months. And as we've seen before, we always have to express our time in years when it comes to calculating these things. So to express this in years, we only have to divide 9 by 12, and this can be further reduced to 3/4. Interest is equal to 7,651, and n is equal to 4 because our interest is compounded quarterly. So amount equals principal plus interest, and the principal here is 125,000 with interest as 7,651, and that amounts to $132,651. So we know that our amount, the formula for our amount is P1 plus R over N raised to the power NT. Amount is 132,651, and that's equal to 125,000. 1 plus R, which is what we're looking for, over N, which is 4, raised to the power 4 multiplied by 3/4. That's it, time. So this cancels out this, and we're left with 3. So 132,651 equals 125,000. 1 plus R over 4 raised to the power 3. Now what we're trying to do is to make R the subject of the formula here. And to do that, we have to isolate R on this side. So the first thing we can do is divide both sides by 125,000. And if we do that, we have 125,000 here, 125,000 here. So this cancels out this. And we have that 132,651 divided by 125,000 is equal to, so this is equal to 1.0612. 1 plus R over 4 raised to the power 3. Now the next thing is to remove this bracket, and to do that we have to get rid of this cube. Now what we can do is multiply or raise both sides to the power of 1/3. If we do that, we have 1/6 raised to the power 1/3, and we simply multiply this by 1/3. This cancels out this to form 1, and we have now the cube root of 1.061 is equal to 1.0612 is 1.01999. Now if you're wondering how you can evaluate this on your calculator, all you have to do is evaluate 1/3, which will give you 0.33333, and then raise 1.0613 to the power of 0.3333, and you have 1.019999. and that would give you 1 plus r over 4. So we're continuing with the efforts to isolate r here. Now the next thing we have to do is subtract 1 from both sides. So if we subtract 1 from here, 1.01999 minus 1 is equal to, if you subtract 1 from here, this 1 cancels out this one, so we have r over 4. And this is equal to 0.01999 equals r over 4. Now if we multiply both sides by 4, we have 4 times 0.01999, and if we multiply this by 4, 4 cancels out this 4, that's equal to r. So our r is equal to 4 times 0.01999. And that's 0.0799. And what I can tell from this is approximately 0.08, which is equal to 8%. So that's our rate.